before starting on moles, a quick recap on relative formula mass, which is something which is a little bit more simple and one of the building blocks towards understanding what moles are about. The word formula, first of all, I've made a separate video about, and I've given some examples of formulas for different compounds. So have a look at that first if you're interested in that. And before we go to relative formula mass, relative atomic mass is something that is found on your periodic table. And it tells you the number of protons and neutrons that an element has as an average across all the different isotopes. So for example, if we went to oxygen, the relative atomic mass, which is the bigger number, is 16. And that's because it's got 8 protons and it must have 8 neutrons as well. Or for chlorine, the relative atomic mass, the bigger number, is 35.5. That's because it's got 17 protons and on average it's got 18.5 neutrons. Some of the atoms have got 18 neutrons and a few of them have got 20 neutrons. So on average, the relative atomic mass for chlorine atom is 35.5. Okay, so I've put that there. Relative atomic mass is number of protons plus neutrons, and find it on the periodic table. Different periodic tables show it different ways round. In this one, the relative atomic mass is at the bottom number. Sometimes it's the other way round though, and it's shown at the top. So just remember that it's the bigger number. Don't look for which is bottom or top. Look for which one is the bigger number. And that's your relative atomic mass. Relative atomic mass is sometimes given the symbol capital A with a little subscript lowercase r, like that. Okay, so that's for atoms, relative atomic mass. When we then go to compounds, which have got more than one atom in, then we need to know the relative formula mass. And to find that, we add together all the atomic masses for each atom in the formula. It's as simple as that. So let's go through these examples that I came up with in this one. First one, water, really simple, H2O. So we need to add together the masses of 2 hydrogen atoms and 1 oxygen atom. So first of all, hydrogen, the relative atomic mass is 1, so we need to do 2 lots of 1, and then just 1 oxygen atom, and that is 16. So I'm going to add to that 16, and the total relative formula mass is 18. I'll just point out at this stage as well that I've just used rounded up numbers. Different periodic tables will tell you the relative atomic mass to different degrees of accuracy. So some of them will have 3 decimal places. This one's got 1 decimal place. I'm just rounding them up to whole numbers to do these calculations just to make it simpler. When you do them, just use however many decimal places is given in your periodic table. Okay, this example is carbon dioxide, CO2. So that's going to have 1 carbon atom, so 1 lot of 12. And 2 oxygen atoms, so 2 lots of 16. That gives a total of 44. Just to show that we can do this for much more complicated compounds as well. This is caffeine here. The formula is C8H10N4O2. So to lay out the calculation for that one, I'm just going to use my brackets again to show how many and the relative atomic mass for each atom. So I'll start with carbon. There's 8 of them, and the relative atomic mass of carbon is 12, so 8 lots of 12. Hydrogen, I'm going to add to that hydrogen. There's 10 of them. Relative atomic mass is 1, so 10 lots of 1. For nitrogen, it's 14, so 4 lots of 14. And then add to that oxygen, which is 2 lots of 16. Just show it step by step. So next step, I'm just going to work out those brackets. So for at the start, it's going to be 96. The next bracket is 10. Then the next bracket is 56, and then the next bracket is 32. And the total is 194. I'd have got a slightly different number if I hadn't used rounded numbers, but I've just used that as an example to show you. So that's my relative formula mass for caffeine. Last example, slightly different type of compound here, an ionic compound, sodium chloride. Even though it's a different type of compound, still going to do exactly the same thing. I'm just going to use the formula, and I'm going to add together the mass of one sodium atom and one chlorine atom. So a bit simpler this time, just 23 at 35.5. And that gives a relative formula mass of 58.5. Okay, just a couple of things just to add at the end. Sometimes the term molecular mass is used. And this has a symbol a little bit like atomic mass, with a big capital M and a little subscript lowercase r, like that. It's sometimes used interchangeably with the term relative formula mass. It means basically the same thing, except because it's got this word molecular, it means that we're talking about things that are made of molecules. So water, carbon dioxide and caffeine, they're all made of molecules. So what I've worked out here is their molecular mass. But sodium chloride is not made of molecules because it's an ionic compound. So this isn't its molecular mass. It doesn't have a molecular mass. I use the term relative formula mass. So generally, if you see MR, that's what this means, relative formula mass. But it's better to use the term relative formula mass because not all compounds are made of molecules. Last thing is units. The units for relative formula mass are grams per mole, and that can also sometimes be shown as grams mole to the -1, like that. They mean the same thing, and that means that, for example, with sodium chloride, because its relative formula mass is 58.5, 1 mole of sodium chloride would weigh 58.5 grams. And with water, 1 mole of water would weigh 18 grams. And what is a mole, I will cover in a separate video.